1 over cosine x.
And I'd accept this as an answer. You could also write, by the way, secant x, couldn't you?
Yeah, I'll try.
Yes, ma'am.
Can you do that last step again?
Woo! Isn't that fun? Okay, so I was here. You with me there? Okay, so first thing I did is change everything to sine and cosine, right? By getting rid of the tangent. Then I looked and said, okay, well, sine times sine is sine squared. But I was grumpy because I had this fraction, not fraction. We were rooting around for anything we could do. Then we should remember, hey, a fraction plus another thing, we do a fraction, right? We're adding fractions. So how do you add fractions? You need a common denominator, which means you got to put cosine over here. When you do here, you have to do the top as well, correct? So multiply the bottoms, cosine x, cross the tops. Cosine times cosine is cosine squared. Yeah. And then 1 times sine squared, sine squared. It's your hand in the back. Yes, sir?
I was just wondering what that 1 over what's under.
1 over cosine x. Because sine squared plus cosine squared is?
Wait, can you repeat the question? Oh, no.
Sine squared plus cosine squared is?
1.
1! And so I saw cosine squared plus sine squared, that's 1, is it not?
Yep.
And that's how I got rid of that. And that is 1 over cosine x, which could be written as secant x.
Rosny,
Yes, sir?
I solved it by doing like the hypotenuse and adjacent kind of thing, and I got the same answer.
You would. Don't do that.
Okay.
These are going to get really hairy. They're just adding a whole lot of layer of fractions to it.
Okay.
Yeah. That it would work every time. And again, if you swear that you want to do that, I can't stop you because you'll get right answers, but let's not. All right, we're try number 2. We got some rules in play we've learned. Do good algebra. Change everything to sine and cosine. Do good algebra. To what? Cosine A over sine A over.
And then you break down tangent into sine over cos.
Sine A over cosine A, right?
And then that's our own stuff.
Okay. Well, I got fraction over fraction. I can't leave it like that. So what do I do?
Multiply the top and bottom.
What? Don't I flip the multiply? It's this divided by this, so I have to flip the bottom fraction up, don't I?
Yeah.
Yeah. Yeah, so I think you end up with cosine squared. Is that okay with you? So that's cosine squared A over sine squared A. I don't know what else you can do with that. Cosine over sine, though, is what? Cotangent. So I could rewrite this as cotangent squared of A, couldn't I? That doesn't make it better.
What's that answer? What's that?
Cosine squared A over sine squared A. If you want to, you can write that as cotangent squared A. Not required. Which is why it's in here. The book thinks that's clever. I should probably get rid of 2. 3, though, is a lot more fun. Let's do 3, shall we?
Divided by cosine.
Well, there's nothing on the other side, so I can't divide by cosine.
Oh, that's true.
But I can factor out a cosine.
Yeah. I guess you could do that.
I don't know why we do that, but it's fun.
Yeah.
Now I'm going to pause there. Are we with us? No.
I'm lost.
So, you could take a cosine squared out of both of these, correct?
Yeah.
And then if I redistribute it, I end up back where I started, wouldn't I?
Yeah.
So that's okay. I can extract a cosine squared out of there. Why I did, I don't know yet.
Okay.
He's a weird guy.
Okay.
We're going to follow him where he goes. He might have something, though. In fact, he does have something he doesn't know yet. Yes, sir.
So the next thing to do, well, I'm not sure. Maybe you try to make it into secant or cosecant.
Ooh, don't go there. Never go there. Never. That's a rule. Never.
No.
Never. Don't do that. Not unless you hate yourself.
Is it in radians though, or is it?
Doesn't matter. But let's say it's in ratings.
Okay. I guess you could try to do cosine times cosine. Or wait, that would do nothing.
It's cosine squared.
Yeah.
Yeah.
So could we put it to opposite and adjacent?
That's not going to help us.
No.
Huh. I'm desperate, right?
Yeah.
I mean, I see nothing. This has not gotten simpler at all.
No.
You do know one thing, though, right? Mr. Mansion, what do we know about sine? We got sine squareds up there. We got cosine squareds up there. What do you know about sine squared and cosine squared?
That they make one.
If they're added, right? In this case, that wouldn't apply. But there's a one over there, isn't there?
Yeah.
What can I make that one?
Sine squared, cosine squared.
I could do that, couldn't I? Now, we're just playing around right now. So if you're like, okay, just relax. We're playing around. Bring us home, Mr. Bellotti.
Wait, how did you get that from 1?
We know sine squared plus cosine squared is 1. That's what you're going to chant all the way home.
Oh yeah, yeah.
All the way home.
Yeah. No,
Skipping.
Yeah. I can't believe I already forgot that.
All the way. Yes.
But,
I can't believe it either. I'm horrified.
yeah.
Okay.
So we could do something.
Well, can't we?
We could take it out of the brackets. Yeah.
Can we do some algebra?
So we could do cosine. Cosine squared
Oh.
0 times or theta.
Theta, right?
Yeah.
Could do that, couldn't I?
Yeah, you could easily do that. But yeah, exactly. And then you can just cross out the sine square, and you just got that negative cosine. So you've got cosine squared negative cosine squared theta. So you get negative cosine to the order theta. Well,
Now that was pretty desperate, wasn't it?
yeah.
Like we went off the rails there, went sideways. But I want to point out something interesting to you. If sine squared theta plus cosine squared theta equals 1, if that's true, and it is, then there's a couple corollaries, like sine squared theta equals 1 minus cosine squared theta. Is that not true?
Yeah, that's true.
And if I had cosine squared theta, that's equal to 1 minus sine squared theta. Agreed?
Yeah.
So here's 2 more things that come from this one important one. That's more important than you think, because if you look at this expression to begin with, it was sine squared theta, cosine squared, no, was it? Was it? It was. Now, I know how to add, subtract, divide, multiply cosine squareds, or cosines, don't I?
Yeah.
What's causing me to not be able to do that in this case? Right? That's my problem. The sine squared's in my way.
Yeah.
If I have this in my toolkit, what can I change sine squared to?
1 minus cosine squared.
And then everything be cosine, and I could do it like I know how to do algebra. It's a sine and cosine that's causing me the headache, right?
Yeah.
So if you have a sine squared and everything else is a cosine squared, or you have a cosine squared and everything else is a sine squared, you can change that one out of there. It has to be squared. Let me make it as Ms. Krolik.
A little,
A little?
I think so.
A little bit more? Okay, good. So that's fine. Okay, so then Ms. Krolik, what can I change the sine squared to?
1 minus cosine.
1 minus cosine squared theta times cosine squared theta minus cosine squared theta. Now what do?
You change the 1 inside.
Wait, what? No, I would not do that because that's what I did to get here.
Okay,
But I could distribute, couldn't I?
yeah.
Just do good algebra, right? And this would give me a cosine squared theta minus a cosine to the 4th?
Yeah.
Yeah. Cosine to the 4th theta minus cosine squared theta, right?
Yes.
So if you see a cosine squared and everything else is a sine, you can change cosine to 1 minus sine squared. Also, the corollary, right? If you see a cosine squared and everything else is sine, I just said that one. If it's sine squared and everything else is cosine, you can turn the sine squared into 1 minus cosine squared. Does cos make sense?
Yeah, but why can't you just do cosine squared theta minus cosine squared theta at the start? Why is that not?
Because these are multiplied. You know order of operations, don't you?
Yeah.
Yeah, so I have to do that first.
Oh.
And I don't know how to do that. But by changing 1 minus cosine squared, suddenly I can do stuff. Is that good?
Yeah.
Do not forget algebra. This is a heavy algebra chapter, right? We're trying to line things up trigonometrically so we can do good algebra is what this boils down to. Right? Because all those problems so far have been change sine and cosine around a little bit, do some algebra. That's going to be the bulk of this chapter, frankly. All right, pausing my